Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? We are going to show you something on photogrammetry. We want to show you how to calculate data for flight plan. You know, in school sometimes we call it the seven formula or something. Sometimes it can be more than seven, depending on the data given to you from the, let's say, on the question, right? Good. So thanks for coming to class. If you're coming to the channel for the first time, you can encourage us by subscribing. And if you're a returning viewer, thanks for always checking up on us. Now the question is that an area that is 54.16 centimeter long and 51.51 centimeter wide on a map. Now, this is actually very important because when you fly over an area, you don't actually measure in centimeters. You measure in either meters or kilometers, right? Therefore, having cm as our unit for the dimension of the area shows that we need to pay very good attention. That's why you saw on a map, right? Please pay attention to that. So an area 54.16 centimeter long and 51.51 centimeter wide on a map is to be photographed using a 209.5 millimeter focal length for the purpose of topographic mapping. Given that the photo format is 180 by 180 millimeter, like 180 millimeter by 180 millimeter, the average photo scale is this, which is 12 in 1 in like 12,500, right? Effective at an average height of or average elevation of 305 meters above mean sea level, with overlaps at 60% and 30%. That's is a side lap and fore lap, right? Good. Now they say the question is that we should calculate what the necessary data for the flight plan at a scale of 1:40,000. Now, if you remember from the beginning, we already had a scale, right? A scale was given to us, which is what 1:12,500, right? Good. And if you also remember, we were told that the area, or let's say the dimension of the project area where that was photographed is 54.16 centimeter and 51.51 centimeter. These dimensions are actually what on very small, let's say, unit, right? Good. Therefore, we need to change this dimension to the equivalent dimension on the ground. Are we together? So that's the essence of having what the two units. One of the units, one of these two scales, right? That's the essence of having the two scales. One of these two scales, which is 12,500 and 40,000, right? Good. 1:12,500 and 1:40,000 would help us in converting the dimension of the project area to the equivalent what dimension on the ground, right? So from the question, we have the focal length to be this, we have the average photo scale to be this, then we have the photo format, that's what PF means, to be 180 mm by 180 mm. Then we also have what the average height, actually that's small letter h, to be 305 meter, right? 305 meters. Then we have the map scale of 1:40,000, overlaps, which is P and S, of 60% and 30%. So these are some of the information we can extract, or these are some of the data we can extract from the question, and we are trying to make meaning to it, or we'll try to make meaning to it, right? Remember this fundamental formula, which is what photo scale equal to focal length over what flying height. Now when we want to make the flying height the subject of the formula, all we need to do is to what is to cross multiply. You know, simple, the way we do it in simple mathematics. So we have F equal to what h multiplied by what the photo scale, right? Therefore h will now be what F over photo scale. So that's how we came about this latter formula. Are we together? Good. So you can just confirm that yourself. So the h is now what the focal length over photo scale, which is equal to what 209.55 millimeter. Now it's very important that whatever calculation you're doing on this flight planning, you include your your units, right? The units are very, very important because we are working with scales that don't have units. So any other parameter that has unit, we must include the unit of that parameter so that it can enable us to what, to know the unit of the answer we are going to arrive at. Are we together? Good. So we have the focal length that we extracted to be what, 209.55 millimeter divided by the photo scale, which means from the two scales we've actually used one of the scale, which is what, the photo scale, right? Good. Which is 12500. Now, for us to simplify this, basically in mathematics, when you have 1 divided by 1 over 2, which means 1 divided by 1 over 2, it means that it's the same thing as 1 times 2 over 1. Are we together? So when you divide by a fraction, is actually the same thing as multiplying by the reciprocal of that fraction, right? Good. So when you have 209.5 divided by 1 over 12500, it simply means 209.5 times 12500 over 1. Are we together? So you can actually confirm these answers from your calculator using either the reciprocal method or the multiplication method. By the division method, you just, if you have your calculator by it, because you definitely need that, you just say 209.5 divided by, then you get a bigger bracket, then you have 1 over, is it 12500, right? Good. So you should be able to come up with 261. Ensure you confirm these answers. You should be able to arrive at 2618750 on your calculator, and that unit is in what, in millimeters, right? Because the only unit we have here is the unit of our focal length, right? Good. If you don't want to do that, you can just do it the way we've done it, because we told you that is actually what, the reciprocal of what, 1 over 20500, and that's same thing as 20500 over 1, right? So we now have 209.5 millimeters times 12500. So you just have 209.5 times what, 12500, and you definitely arrive at the same answer. And remember, the unit we're having here is what, in millimeters, so we don't really need it in millimeters. So for you to convert this millimeter to meter, is the same thing as multiplying by 10 raised to power minus 3. Milli is actually the prefix of, is it prefix or suffix? It actually represents 10 raised to power minus 3, right? Which simply means dividing by 1000. So if you divide that value you have there, please, you need to press these things on your calculator. You should be able to arrive at what, 2618.75. So that's actually what, the flying height, right? Good. Now there's something else we need to check out. So we need to now alternatively just get the altitude. So the altitude will now be equal to the flying height we just calculated plus what, the average flying height that was what, given to us. It will now give us what, the altitude. Are we together? So we have what, 2618.75 plus what, 305. Remember that 305 was what, the average flying height as was given to us what, from the question. So we have our altitude to be this. Then the next thing is, remember we told you we had two scales and we need to convert the map scale, or let's say the map dimension rather. We have two scales and we need to convert the map dimension to the equivalent ground dimension of what, the project area. Now, ground dimension of project area, remember that scale generally is equal to map distance over ground distance, right? That's actually the general denotation of scale. This now implies that your ground distance is equal to what, your map distance over scale. This is just simple change of subject, right? Good. So this implies that your ground distance is equal to what, your map distance over the scale, which is what we have here. And we know the map distance. The map distance are those values, those we don't want to call them tiny values, are these 54.16 centimeter. They are tiny because of the units, right? So you can't just fly over centimeter stuff, right, like that. So we are now going to convert these values, or let's say these values whose units are in centimeters, to the equivalent what, ground dimension using what, the scale. And now, which other scale are we using? This time around we are using the map scale, and the map scale is what, 1 ratio what, 40,000. So we've used the both scales. We used the photo scale and now we are using what, the map scale. The map scale will help you convert the dimension of the project area to its equivalent, let's say, ground dimension. Let's just use that for the purpose of the video. So, having established that the scale is map distance over ground distance and your ground distance is equal to the map distance over scale, this now implies that for the 54.16 centimeter, which is the length because it's actually the longer side, for the 54.16 centimeter, the ground distance will be what? 54.16 centimeter, which is the map distance, over what? The scale, which is what? 1 over 40,000. So, as we have explained earlier, when you are dividing and you have another division, it simply means you multiply what? By the reciprocal of the second division. Are we together? So, this 54.16 centimeter divided by 1 over 40,000. If you don't want to take it that way on your calculator, simply means you have what? 54.16 multiplied by, instead of 1 over 40,000, it will now be multiplied by 40,000 over 1. I know 40,000 over 1 is the same thing as 40,000, right? Good. So to just go over it straight, you just have what? 54.16, because we are still trying to confirm the values, multiplied by what? 40,000. And remember that we have our units in what? In centimeter. So we are having 2166,400 centimeter, right? Good. 2166,400 centimeter. And for us to convert this centimeter to meter, we just, and centi is 10 raised to power minus 2, right? So you either multiply this answer by 10 raised to power minus 2, or you just divide it straight by 100. So if you do either of the two, you should be able to come up with what? 21,664 meters, right? Now that 21,664 meters, if you still want to convert it to kilometers, you divide it, rather, you divide it by 1,000 and you get the equivalent in what? In kilometers. I hope you are confirming these values on your calculator. Ensure you do that. Now also for the 51.51 centimeter, which is what? The width, right? For the 51.51 centimeter dimension, which is the width, we have what? 51.51 centimeter times what? 40,000. I hope you've understood the explanation of how we got that 40,000, right? Good. So you should be able to have 20,400 on your calculator. Then you divide that by what? 100 to get the equivalent in meter, which is what? 20,600 meters, right? Good. Then you divide that answer by 1,000 to get the equivalent in what? In kilometers, right? Good. So when you do that, you should be able to, we are trying to get that on our calculator now. So when you do that, you should be able to come up with what? 20.604 kilometer. So these, or let's say, yeah, therefore the dimension of the project area will now be 21.66 kilometer by 20.60 kilometer. So you can see that 54.16 centimeter and then 51.51 centimeter is actually very small compared to what we have here as 21.66 kilometer and 20.60 watt kilometer as the ground dimension of the project area. So two things, or let's say, it's very important you need to pay attention to what the both scales you saw there on the question, right? Because one of them will help you convert the dimension of the project area to its equivalent what? Ground dimension from the map dimension. Are we together? Good. So having established that, let's move to the next one, which is actually the beginning of the calculation of the necessary data. So we have what? The ground distance between principal point. That's what this GDPP means. Ground distance between principal point equal to the length of photo format. That's what this LPF means. Multiplied by 1 minus F, right? Good. Divided by what? The photo scale. Are we together? So the length of the photo format, remember that the dimension of the photo format was what? 180 mm by 180 mm. So the length is 180, the breadth is also what? 180 mm, right? So it simply means we have 180 mm multiplied by 1 minus F, which is 1 minus 60 over 100, right? Which is one of the overlaps, right? Which is one of the overlaps, as we can see here. So we have 1 minus F divided by the photo scale. This time around, we're using the photo scale, not what? Not the map scale. Are we together? Pay attention to when each of the scales are used, or let's say when the different scales are used, right? Good. So we are using the photo scale this time around, divided by the photo scale of what? 1 over 12,500. So we are still doing the same set of calculation. The first thing is that let's look at what we have in this bracket. Remember that 60 over 100 is the same thing as 0.6. Ensure you confirm these values on your calculator, which means we have what? 180 mm times 1 minus 0.6, right? Multiplied by 12,500. So how do we get this 12,500? Yeah, you guessed right. We got it up here because it is being divided by a fraction here, and you know this fractional division simply means that you multiply by the reciprocal, right? Good. So multiply by 12,500 as we've been explaining earlier. Multiply by 12,500. So you can just press everything directly on your calculator. But to avoid ambiguity, ensure you put everything in a bracket as you can see it on the screen. So we have 180 mm. You can't write mm on your calculator. So you have 1 minus 0.6, right? Then you have multiplied by 12,500. So if you done that, you should be good to go, right? Good. So you should be having 900, yeah, 900,000 mm on your screen. Ensure you press these things on your calculator. So you have 180 mm multiplied by 1 minus 0.6 times 12,500. So you should be having what? 900,000 mm on your screen, right? Good. So mm, as we told you, this other m is the milli, the prefix or the value is times 10 raised to the power minus 3, which is simply dividing by 1000. So you should be able to arrive at what? 900 meters. Are we together? Ensure you get these values on your calculator. So you should be able to arrive at 900 meters. So this 900 meters is actually what? The ground distance between principal points. Are we together? Good. So we have what? The ground distance between adjacent point, which is what? The width of the photo format multiplied by 1 minus what? S. And that's the other part of the overlap, right? We have is it side lap and fore lap, right? Good. So we have the width of the photo format multiplied by 1 minus S, and we've told you earlier that the dimension of the photo format is 180 mm by 180 mm. So we still have 180 mm here, right? Good. So 180 mm multiplied by 1 minus 30 over 100. Are we together? So by having 30 over 100, it's divided by the photo scale. So it simply means 30 over 100 is what? 0.3. So you just run through the calculation as we've explained earlier. So you should be having 180 multiplied by, we have 1 minus 0.3, then multiplied by what? 12,500. Are we together? So if you've done that correctly, you should be able to arrive at 15,750,000 millimeters on your calculator. Are we together? So for you to arrive at a value in meters, you still divide that answer by 1000, and we've explained that dividing by 1000 simply means multiplying by 10 raised to the power minus 3 because of this milli. Are we together? Because of this milli. So you should be able to arrive at what? 1575, that's 1575 meters, right? Good. So that's actually what? The ground distance between adjacent points. Are we together? Now we are almost done. We are trying to calculate the number of photos per strip. That's the strip, the number of photos you are going to acquire as you fly over the strips, right? Good. So the first thing is what? The length of the project area over the ground distance between principal points plus 4. Are we together? So the length of the project area as we have calculated is what? 21,664, right? Good. That's 21,664 as we have calculated. Where is that value? So we have good. We have 21,664 as we've seen it here. Then the width is what? 20,604, right? Good. So that's the length of the project area. So 21,664, or let's say 21,664 divided by the ground distance between principal point, which we calculated a while ago, plus what? 4. So if you do that on your calculator, you should be able to come up with divided by 900. So you should be able to come up with what? 240711, right? Then you now say plus 4. So that should give you what? Something like 28011, which is approximately what? 28 photos per strip, right? Are we together? Good. Then the next is the number of flight lines you are going to have, right? You are going to have on this flight plan. So that's actually what? The width of the project area. The width of the project area divided by the ground distance between adjacent points. The ground distance between what? Adjacent points. So the width of the project area as we calculated earlier is what? 2604 divided by the ground distance between adjacent points, which is what? 1575, right? Good. And that should give you plus 2. Sorry, we didn't add this in our formula, plus 2. So that should give you 13,08192. So plus 2 should be able to give you what? 15.08. So if you approximate that to the nearest whole number, you have what? 15 strips. So finally, or not really finally, but for the total number of photographs you are going to have on this flight is actually what? The number of flight lines multiplied by the number of photos per strip. So that will be what? Approximately 15 by 28, and that's what? 420 photos. So that's the total number of photographs you are going to have on this particular what? Flight. So if you are asked to determine the time interval between exposure, then you would have been given some extra information like what? The ground speed of the aircraft, right? Good. So if you are given that other information, you are just going to insert it into this formula by using the ground distance between principal points in kilometers, which we already have at top, over the ground speed of the aircraft in kilometer per hour, right? Multiplied by what? 3,600 seconds. So the value you are going to have will actually be in seconds. So that is if you were given what? This other part of the, if you are given this other part of the question or something, if you are given this other parameter, right? Good. So with that, you are good to go. So good luck in your exams, in your tests, in your assessment, or maybe in your personal study. We hope we've provided a solution to this particular solving problem. We hope you enjoyed it. And if you have questions, contribution, you can leave it on the comment section, and we hope to get back to you as soon as we can. So until we see you again, keep being best at what you're doing. Yeah, just keep doing what you're doing, do it very well, and have very good time for yourself. Bye.